All right, we're on to mesh analysis. This is another DC analysis technique for solving circuits. Typically circuits with multiple loops. It makes no sense to use mesh analysis for circuits that only have a single loop. That's basically just KVL. So what mesh analysis is, I've actually had previous students liken it to KVL, and I think it is very similar to KVL. And it's going to use KVL in the steps. It's basically just defining a equation, a KVL equation for each loop in the circuit, and then solving the resulting system of equations. It's very algebraic, very systematic. If you're very systematic and you really like to just chop through algebra, you might really like mesh analysis. Okay, so this is what we're going to do. Let me go ahead and draw a circuit. Let's go ahead and call. So each one of these is clearly a loop. We've got a loop here and we've got a loop here, right? And we're going to go ahead and ground this. And the first thing that we need to do is define loop currents for each loop in the circuit. And so what I'm basically saying is I'm going to have a current that flows in this loop, and I'm also going to have a current that flows in this loop. And I can define them clockwise or counterclockwise. It doesn't make any difference. The math will all work out, whatever you want to do. Some people like to just always define them both clockwise. I personally like to define one clockwise and one counterclockwise, and you'll see why when we solve the example. But what we're going to do is we're basically going to define the currents. Let's call this one I1, and I'll do it the way that I normally do, which is one clockwise and one counterclockwise, and I'll call this one I2. And then what we do is we just note that the current flows the same direction in each loop through each resistor. Okay, so basically the current here is I1, the current here is I1, the current through the battery is I1, but that doesn't really matter. And then in the second loop, we've got the current here through that resistor is I2, this resistor is I2, and this resistor is I2, right? Okay, so it looks pretty chaotic now. That's why we just draw the loops normally. But just so that you know that's what's happening is this loop indicates the current flowing through this resistor and this voltage source are all in that same direction, right? And the same goes for this loop and these other arrows, right? It just tells me that the current's flowing, or I'm defining the current to flow counterclockwise in that loop. It doesn't necessarily mean the current's flowing counterclockwise because, of course, this value could end up negative when we solve this whole thing. All right, so anyways, define loop currents for each loop in the circuit. We've done that. We called one of them I1, we called the other one I2. Let me go ahead and erase all this other crap. Oop, that's not crap. And I think I erased the I2 label as well. Okay, so we've defined loop currents for each loop. Then it says to write the KVL expression or the loop equation for each loop as the second step, okay? And so what's important is I know that current flows from plus to minus, so I need to label the plus and minuses on my resistors. So in this case, it would be like this. All right. And so what I'm going to do is just like KVL, I'm going to go around the circuit and I'm going to write a KVL expression for each loop. The only difference in this circuit versus a regular circuit where we just use KVL is that one of the resistors has two currents contributing to the total current, right? It has a current flowing I1 and I2, which are both contributing to the total amount of current flowing in that circuit, right? That's just KCL telling me I've got these two currents summing, and that creates this circuit. So when we get to that resistor, we just sum the two currents, but it does get a little bit confusing for some students. So let's go ahead and call this resistor R1. I'm going to call this one R2. This one will be R3, and this will be R4. And so write the KVL expression or the loop equation for each loop. So I'll just go ahead and start with this one. And let's just say that this was called V in. So my voltage across that source is going to be equal to a value V in. I'm going to go around my loop and write the equation just like I do in standard KVL. So for loop 1, my equation would be going across this voltage source, I've got V in. Then I'm dropping across the resistor R1. And of course, my voltage drop is equal to I1 times R1, right? Ohm's law. Then I get to R2, and my drop is going to be I1 plus I2, right? That's my current times R2. And this whole thing's going to be equal to 0, right? That would be the equation for my first loop, okay? Because I know that the current here is I1 from this loop. The current here is I2, but then R2 sees both of those currents, so I have to make sure that I sum them. And just so you know, the reason why I draw one clockwise and one counterclockwise is so that I get this sum here, just so I don't get a negative sign there. Sometimes the negative signs get a little bit confusing. Okay, so then the second loop, I would do the same thing. I would go around starting from here, and I'd go across R4. I'm dropping by I2 times R4, okay? And then when I get to R3, I'm dropping by I2 times R3. And then when I get to this resistor, again, I'm dropping by I1 plus I2 times R2 equals 0. Okay, and what I'm left with is two equations. Ideally, my resistor values would all be known, so those would all be known values. Vin would be known, and all I would be left with are the variables for all the currents. I1, I2, I2, I1, I2, I1, I2. And what I can do is I can now solve the resulting system of equations however you like, substitution, elimination, and you can go ahead and solve for I1 and I2. Once you know those currents, it's very trivial to solve for the node voltages in the circuit, and that is mesh analysis. So you really just go ahead, define your loop currents however you like, define the pluses and minuses accordingly across the components, and then go ahead and write the KVL expression for both loops, or however many loops there are. It could be up to as many loops as you want. And then you go ahead and solve the system of equations. And once you solve the system of equations, you will know all of the currents in your circuit. Okay, so that's the general process for mesh analysis, and in the next video I'll go ahead and start the example. I'll try to get through it. If not, I'll split it up into 2 videos.